let's walk through. Okay, so for our warm-up today, it was a nice area volume arc length problem. I'm gonna kill this.
Wow, you're so violent, right?
Go to the scoring guidelines, yes. Okay, so the first part, part A, each part was worth 3 points. So I'm hoping for part A that you all just were okay with it. It was a point for your setup, a point for your antiderivative, a point for the answer. Area, remember, is just the integral of top minus bottom, right? Top function minus bottom function, bam.
Wait, did we have to do it as an integral?
Yeah.
I just did integral from 0 to 1 of xt to the x squared plus, and since the bottom half, like pretty much anything below the x-axis is basically a triangle.
Oh, so you did this area and then added the triangle?
Yes.
Yeah, but you still needed an integral.
Oh,
Right?
okay.
Yeah. Okay. There's no way to do it without an integral, but yes, you could split it and do geometry for the bottom half and an integral for the top. I don't know if you're actually making your life easier or not, but yes, that would be fine. Did you get the same answer?
Yeah, same answer.
Good. Mathematically correct is correct, it's fine. So let's use an appropriate mathematical method. That's fine.
So I still get all 3 points, right?
Is your integral,
How would you
did you
write-
anti-differentiate and
Oh,
everything,
no,
like
you
show your
do-
steps?
Do you want to find like horizontal
Well,
alignment?
I'm writing a thing for perimeter.
Oh, well, like this is from here to here, it's just this minus this.
But then if it was like this,
So you can find the
Go for it, yeah, that's good.
Yeah.
Okay,
top equation
so
is
the
like
next
1
question
and the bottom equation
said
is
to
like
find the
1
volume if you revolve this
How would you?
about the line y equals -2.
you do know you.
Now-
if it was
I mean, I
horizontal.
know how to write the answer.
-2, if we plug a 1 into this function is y equals -2x, right? So if you plug a 1 in, this point is the point 1, -2, right? So y equals -2 is a horizontal line right there, right? Okay, so we have two methods for finding a volume by revolution where there is space between the region and the axis. Name those two methods.
Washers.
Washer
Shell.
and shell, right? Washer and shell. Normally, to make life easier, we use washer when it's a horizontal axis and shell when it's a vertical axis, and that way we can always integrate with respect to x, right? Okay, so this one is a horizontal axis, we want to use washer. In case you've forgotten washer, okay, so in case you've forgotten washer, you go from your axis to your farther away function, and that's big R, and you go from your axis to your nearer function, and that's little r, right? We had big R squared minus little r squared. So big R, top minus bottom, would be whatever, it's x e to the x squared, right? Okay, minus -2, and then little r would be the bottom function, -2x minus -2. Does that make sense? So your volume is pi integral big R squared minus little r squared. All right. So can I erase this or you guys? Got thumbs up. All right, good. All right, because I got to show you the answer. So that was 3 points. And the points were distributed like this. So you got 1 point for what's called the limits and constant. The constant is the pi that's in front. So you get 1 point if you have just pi and an integral from 0 to 1, right? Even if you just have like a picture of a cat inside the integral, as long as you have that, you've got a point, right? Okay, so then your integral is worth 2 points, right? So this, I don't know how they split up their points, if they go 1, 1, or whatever. To me, a lot of times what they'll do is they'll say, well, they had these correct, but they forgot to square, that's -1, right? Or something, they switched them, like they had little r minus big R, something like that, and then it's -1. They usually like give start and then take off, more than build up, so. Anyway, yes?
Is forgetting DX automatically point off?
Yes, you know, it varies from whoever wrote the problem, it's their decision. But I will tell you, I am seeing more and more notes on these free response problems where the readers are taking off for notation.
Okay.
So I would be very clear and meticulous with my notation, right? Okay. Third part. Third part said define the perimeter of the region. So, to find perimeter, perimeter is the distance all the way around, right? We have line, line, curve. So it's funny today, I've had a lot of students who got the curve and couldn't get the lines, right? So let's talk lines first. So we already figured out this is the point 1, -2. How do we get this top point? Well, this is the top curve, right? Just plug a 1 in, then you get, this is the point 1E, right? So, this line, we have, this length is 2, this is obviously not drawn to scale, right? Okay, so 2, 1, so this is root 5 just by Pythagorean theorem, right? And then, from here down is the length of 2, from here up is the length of E. So you have root 5 plus 2 plus E. So there's 2/3 of your perimeter. Okay. Although I think that's still just all like the point, right? I think that the arc length was the big part. So, yes?
If you did an integral for the line, like that'd still be right?
That's fine.
Okay.
Yeah, absolutely. Okay, so now we need to find the length of the arc. In case you've forgotten an arc length, right, we would have the integral 0 to 1 of, and then it's root 1 plus f prime squared, right? So you need the derivative of that guy, ha. What rule do we have to use? Product rule, right? Don't forget product rule. Okay, good. Okay, so y prime is e to the x squared plus x times e to the x squared times 2x. So you have to use chain rule. Everyone okay? Okay, good. All right, and so then there's your derivative, which you can you could pull out an e to the x squared if you want. Kind of times 1 plus 2x squared. Right, squish that in there and square it. And you just had to write setup, right? You didn't have to actually do it. So,
This is really funny.
yeah. So you got a point for finding the derivative, a point for your integral, and then a point for your answer, which means everything else. So,
Point for circling the ball.
So, no points for not calculus finding the other perimeters.
you get 1 point for, it's a point for your derivative, right? So if you found your derivative correctly, that's a point, right? Then you got a point for the integral, include the dx, right? A point for that, that's your arc length. And then a point for the answer, which to me means, and the integral, whatever you used for arc length, plus this stuff, so that's how I'm thinking in my mind, yes.
So if you got the integral wrong, then you got
No, because I think if you got this, they counted that. Like they took whatever integral you used, plus
You
that,
also get a point for the derivative.
plus you get a point if you got the derivative, right?
So if you got the integral wrong, you still got 2 points.
You could get 2 points.
Unless you got the
potentially.
integral wrong because you got the derivative wrong.
Right, unless if you got the derivative wrong,
In which
then
case-
the most you get is a point, yes.
How do you know, like, when you don't have to evaluate the integral?
Because it said write but do not solve. Yeah, make sure you read those directions, because boy, you do not want to be wasting time solving integrals that you don't have to, right? If you ever have area and volume in a no calculator free response question, chances are they're gonna say write but do not solve, because they just want to see if you can set it up. You know, and the other thing to think about, Jack, along your question, is sometimes, say you messed up the derivative, say you didn't use product rule, right? So say whatever the derivative is, say you just said the derivative was e to the x squared, right, whatever. Okay, sometimes if you have the correct arc length setup using whatever derivative you got, they would probably still give you the point for the integral and just not for the derivative.
Okay.
So a lot of times, they're very nice about that. So say you mess up this, but you do incorporate it correctly into your setup for that, then they might give you that time. So you can mess up the derivative, and my guess is still get 2 points. Good. Any other questions before we move on? All right, I have handouts.
Oh yeah, what was the average, do you know the average score for this problem?
I can look. Here, wait, let me hand
Yeah.
these things out, and then I will.
You're probably right, Paul.
6 points.
Yes, you have a review quiz for this.
Oh, you were not.
Why?
I will get you one. 1, 2, 3, 4, 5.
We still bring that one. Come on, Will. Dude, just have our energy.
And I have
Good math.
polar graph paper. Now, yeah. Today is polar day. Now,
Polar day? Why is it polar? You're really hot outside.
4, 5.
Hilarious, Brian, I'm not.
Hey,
Hilarious.
polar graph paper, if you need more, 1, 2, 3, 4, 6, 8. And this honestly, it is not the best polar graph paper. I might try to find some better stuff. But, because the radius on this is only 3 and sometimes you need a bigger radius. Anyway, but if you need more polar graph paper, I linked the polar graph paper on my website. You can just pull it up and print more if you need some. Okay, so you guys wanted to know the scoring statistics
I do. Since second
for
grade.
this.
What?
Okay, so this was question number 5. The average score was a 4.45.
Ow.
Yeah, question 3 was the highest.
Oh, it's probably quit.
We are actually working through this whole exam, we're just gonna do it backwards. Question 3 was your graph, this is the, it's a graph of that. It's curve sketching, increasing, come down, and blah, 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 simple stuff. So anyway, today we did 5, on Monday we're gonna do 4, which is a training problem, I love that. Tuesday we'll do this, and then by Wednesday, if I'm right, it's either Wednesday or Thursday, we will have the knowledge to be able to do that. Won't that be fun, right?
No, not really.
Yeah. Okay. Yes,
That would be.
yes, absolutely. We will do those prior to your final, because it's probably okay, we will, I would be happy to do some of those. Alright. Okay, so, today we're doing polar. I know it's a different opening today because I'm using a pre-calc today. Quiet please. So, we use rectangular coordinates for all of our traditional graphs. We use polar when we have to graph something that's kind of unusual. For example, okay, circles, you could go either way, but cardioids, leprechauns, roses, and lemniscates, right? So, yes. Oh, and then it says, what? Yes.
Is there a difference between using a polar and a parametric?
Yes.
Like in terms of ability of graphing? Can a parametric graph the same types of functions that a polar coordinate can?
Yeah, we're talking about completely different things. So I'd have to sit down and take a look. So, see how they relate. I think we do put them all together. I gotta look and see. I will check and see. Okay. Alright, so, you do not have to memorize these, but you will, over the course of the next couple of days, probably become fairly familiar with them anyway, because we'll be doing a lot of this stuff. So, cardioids, which I did this when I was in high school. I remember doing these graphs when I was in pre-cal. I did not put it together until today, third period, that a cardioid is called a cardioid because it looks like a heart.
Cardio.
Anyway, so there we go. Now we know, right? Okay. So that doesn't tell me why a limicon is called a limicon.
Why the rose does not look like a rose?
Okay. So roses are called roses, and the individual parts of the rose are called petals. Okay, so if they talk about petals, they literally mean the petals of the roses. And lemniscate, there is a song in the, when you learn numbers, Schoolhouse Rock. Do you guys ever watch Schoolhouse Rock?
No.
Okay. Then when they're teaching about 8, it's like, can you skate a figure 8? Anyway, so that's what I think of with lemniscate, right? Lemniscate. Anyway. Okay, all right. So I always look at Amanda. She's not here. I look at Claire today. You're my Amanda today. I hadn't realized how much I look at her, but now I'm probably freaking out with Claire because I look in that direction all the time. All right. A polar coordinate describes the location of a point in terms of direction and distance, right? Direction and distance, or in other words, direction and magnitude, right? Ooh, what does that make us think of? Vectors! Oh, whatever the related symbol. Okay, all right. Okay. So R is the distance from the origin or pole. When you are graphing in polar coordinates, the origin is not called the origin, it's called the pole. So just be aware that if the book says something like, find the distance from this point to the pole, that means the origin, all right? So, because I had not been that familiar with that term either, and I'm like, what the heck is the pole? So now I know, it's the pole, it's the origin. Okay, so think of that as like, I think it's like the North Pole, right? There's the pole, and then everything goes away from the North Pole. All right, and then theta is the angle, it's just like normal. It's just like on your unit circle, right? Theta is, it's just the exact same as on the unit circle. Okay, so R is the radius. R can be positive or negative. If you have to graph, this is actually going by pi 6, so this would be pi thirds right here. So if we had to graph a radius of 3 on pi thirds, we'd land here. If we had to graph a radius of negative 3 on pi thirds, we go to pi thirds and we actually go backwards and land here, right? So a negative radius sends you back in the other direction. So radius tells you how far out you go, and then the angle tells you where you are. You always want to do your angle first and then your radius. And which we'll get into why that bugs me. So anyway, here's why it bugs me. Ordered pairs, and I haven't really researched to see if there's an answer why, but ordered pairs are written XY, input, output, right? But ordered pairs in polar are written output, input, R theta. I don't know why, but that's how they are. So it bothers me because you want to make an R theta chart, but you can't. You have to make a theta R chart. And so why don't we write it theta R? Why do we write R theta? I don't know.
I'm just gonna take a guess, but I
Okay.
think you can decide R, but you can't decide theta.
Okay, but that's kind of my point, yeah. Because R is your dependent variable, right?
Oh, wait. Oh, it is.
It's backwards.
Oh,
Yeah, it's backwards.
never
You
mind.
can decide theta, but you can't decide R.
Wait, why can't you decide R?
I'll show you. There's a reason. I'll show you. You can. It's just like saying you can decide X. Well, you could decide Y and find the X, but you won't, right? Okay. All right. So we have here R theta. When you have to plot a point, first you do the angle, 7 pi 6. So remember, this is 0, this is pi. If we're in pi 6 mode, this is 6 pi 6, right? So 7 pi 6 is 1 past. So we're at 7 pi 6, so we're on this line. We want a radius of 2, 1, 2, and we draw our point. This is on your sheet too, I don't know if you're following along, but it all is on your sheet, right? So, anyway, okay, so I want you guys to take a minute and do the next couple of points. I tried to find a background color that was the same color as your paper. Can you do the weekly quiz?
So why can't you do the R first?
You can find R and then follow along to the angle, that's fine.
Oh,
Whichever works better for you is fine. When you're plotting points, it's no big deal. It's when you're plotting equations that it gets
oh,
hard.
gotcha.
Yeah. Yeah, I do. See if you can figure out where 2 is. Yeah, the hardest one is 2, too. All right, everyone okay with negative, if you do 4, negative pi thirds? Negative pi thirds is down here, and then the radius is 4. Okay? Good. Okay, negative 3 pi fourths. So now we have a negative radius, so we go to pi fourths, that's our line, but we go backwards 3. So we're actually there. Is that good? Is that okay? Can't tell.
I got dry ones.
Yeah, you guys have a,
It's a best one if you have experience.
yeah,
I've tried one.
These are nice.
yeah, those are nice. I hate this graph paper. I'm gonna switch to this graph paper on here.
You should.
Yeah.
That was about to
Okay.
come
All right. Negative 4, negative 3 pi halves. So negative 3 pi halves, we go backwards to 3 pi halves, so we're on this line. But we have to do a radius of negative 4, so we actually end up down there. Does that make sense?
So, yeah, so we have to do it based on the omega first.
You could have done a radius, you know what, there's an argument for always doing the theta first. Yeah, because that negative radius is gonna throw you if you do the radius first. I guess you do a radius and then.
And then you just go
You can do
negative 3, or negative
Think
3
about
pi.
it.
Okay, I get that,
Both of them could work. I think the theta is generally a little easier.
yeah.
I don't think so.
All right, last one, 2, 2. Just because you are a radian doesn't mean you have to have a pi in your angle, right? Okay, so we know this is 0, we know this is pi. Pi is around 3, right? Pi halves is around 1.5, roughly, right? So we need to know where 2 falls. Well, that's pi thirds. This is 2 pi thirds. 2 pi thirds is 2 times pi over 3. Pi over 3 is a tiny bit bigger than 1, because pi is bigger than 3. So 2 pi thirds is a little bit bigger than 2. So we're just going to be just a little bit before 2 pi thirds with a radius of 2. So somewhere there. My pen is off a little bit, but somewhere just to the right of that 2 pi thirds angle. 2, 2. Okay, any questions on plotting polar? All right, it's time to learn how to go back and forth between polar and rectangular. So, four equations to learn. First is we're going to relate r and x and y by Pythagorean theorem. How can we relate r, x, and y by Pythagorean theorem?
X squared plus y squared equals r squared.
Beautiful! X squared plus y squared equals r squared. Now from that, we can deduce that r is plus or minus the square root of x squared plus y squared. I never use this. I don't like this. I just use that. If I have to take the square root of both sides, then I will, but I like doing r squared. It feels cleaner. All right, theta can be found in terms of x and y with which trig ratio?
Tangent.
Just x and y.
Crap.
Inverse tangent.
Tangent, right? So tan theta is y over x. And if you wanted to solve for theta, then you could do arctan y over x as theta. But I just know tan theta is y over x. So these are my two go-tos from this page. This one.
I'm pretty sure you did that like freshman year. You had like two in the same day, like once in the morning and once in the night.
Okay, so we are going to convert a rectangular coordinate to a polar coordinate. So we're going to convert -2, 2 to polar. And we have some restrictions that are given. We have that r has to be positive and theta has to be between 0 and 2 pi. And then they give this hint, use the original point to determine the quadrant. All right, so we have an x and y. We need an r and theta, right? So how does r relate to x and y again?
X squared plus y squared.
X squared plus y squared equals r squared. So everyone find r. Okay. Don't worry, we'll
Oh.
edit.
Oh,
Yeah.
look at that, Cole.
Okay, so when you solve for
Look
r,
at
you get
you.
plus or minus 2 root 2, right? Okay, good. Now we need to find theta. How does theta relate to x and y?
B squared.
Tan theta is y over x, right? Yes.
Wouldn't it just be square root of 32 root 2 since we get
Yes, we're gonna get into that in just a second. Yes. Okay, so your tan theta is y over x. So go ahead and see if you can find theta.
Yeah, that could be two. Because you could have it invisible. Oh wait, but since you know that x is negative, it has to be in the second quadrant.
That means the y has to be negative. Equals y over x for tangent. Wait.
It has to be.
Oh, no, yeah, you know it's in the second quadrant. Yeah.
Oh, yeah.
Okay, so our tan theta is -1, so our theta is the inverse tan of -1, which is 3 pi-4 or 7 pi-4, right? So we can get a couple points out of this. We can get 2 root 2 3 pi-4 or -2 root 2 7 pi-4. Both of these give us the exact same point. So let's just take a look at this for a second. If we plot the original point, -2, 2, we land right here, right? If I plot 2 root 2 3 pi-4, so I go over to 3 pi-4 and I go out a distance of 2 root 2, it's around 2.5, right? I land on that point. If I plot -2 root 2 7 pi-4, that means I go around to 7 pi-4 and I go backwards 2 root 2 and I land at the same spot. So we actually have multiple representations of the same point, right? However, we have some restrictions, right? R had to be positive and theta had to be in here, and the only one with a positive R is this guy, so that's our actual answer. Does that make sense? Okay, so,
Is there any reason why, you got, so 3 pi over 4, 7 pi over 4, how'd you get those two, polar points? Exactly.
how did I find these angles?
No, not the angles, but the points. The
Oh,
2 root 2.
Oh, okay, so I put an R with each theta. Now if I put the opposite, if I put positive 2 root 2 with 7 pi fourths, I would be in the wrong spot, I'd be over here,
Oh, okay.
right?
So
So
they have,
yeah, you have to
Please
use your
play.
original point to kind of guide you, to let you know which one to
yeah,
pick.
so,
Where's that?
so we have to follow basically the picture.
Yes,
You starting at short again?
or at least think about it a little bit. We need a negative, we need to be, when you have a negative x positive y, you know your second quadrant.
We won the first game,
This is actually an important thing to understand. Rectangular coordinates are unique. Every point on the rectangular coordinate plane, there's only one way to write it, right? The point negative 2, 2 is here, and there's no other name for that point. It is negative 2, 2. However, in polar world, there's infinitely many names for the same point, right? We have this point right here, and we have a million different ordered pairs that would give us the same point, which is why polar graphs can cross over themselves over and over and over, because you can keep hitting the same point as you continue through your radians, right? From 0 to 2 pi to 4 pi, right? So they're all cyclic, right? So anyway, yeah, so there you go. So anyway, this is gonna, it causes a problem when you try to find points of intersection, because you might have an intersection point, but the coordinates are different. You know what I'm saying? Yes?
So is that why it's all rectangular, because you can't have more than one output?
You can. In polar graphs, you can.
No, I'm just thinking why it's.
Oh, I see what you're saying though, but the theta is your input.
Correct.
Yeah. So I don't, if you're asking why is theta the input, that makes sense that you have one output for each input. Sure, but my question is why is the R written first?
Okay.
Yeah, I don't know, but maybe we'll discover it as we go through. Okay, rectangular to polar, to me this is even easier. When you go rectangular to polar, so cosine theta is equal to what over what?
X over R.
X over R. Cosine theta is x over r. Sine theta is equal to y over r. So if we were to solve these for r, you get that, or for x, I'm sorry, x is equal to r cosine theta, y is equal to r sine theta. Have I taught you guys, did we bring up third period and never seen the all students take calculus thing? Have you guys seen it?
No.
Yes.
No.
The all okay, let me just make sure you've all, just have it on the video, right? It's just a little shortcut to remember what's positive and what's negative in each quadrant, right? So, yeah, all students take calculus, all strippers take cash, right? So,
Wow, that's
you have-
hilarious.
So,
Whole,
whatever
Not later.
whatever you have that starts with that letter is positive in that quadrant, and if it's not positive, it's negative, right? So they're all positive first, sine is positive second, tangent's positive third, cosine's positive fourth, right? Anything that's not positive is negative. Reciprocals keep the same sign as the original function. So sine and cosecant are both positive second quadrant, right? All right, so anyway, a little shortcut. The other thing, and the thing that, okay, well anyway, why, I have a really stupid memory trick to remember that x goes with cosine and y goes with sine. So I think, and I know I've taught this year before, but no one in third period remembered it. I think y psi co ho, okay? Y psi co ho. So y goes with sine, right? Cosine goes with your horizontal component, right? Okay, so That was the joke. Apparently,
I thought
like
it was,
that.
I thought it was gonna be like.
Yeah.
X is your color.
Yeah.
Oh, yeah.
So apparently in third period I stretched out part of the horizontal a little long. So, and everyone thought it was funny, right? So, anyway, but there you go. So cosine goes with your horizontal component. So there you go. Okay, y goes with side, co goes with ho. Alright, so find the rectangular coordinates for the point with the polar coordinates -3, 5 pi thirds. These straight up, very simple, right? So we know x, this is r, this is theta, x is r cosine theta. So you literally just plug the r and the theta in and do it, right? There's going to be a lot of trig over the next couple days. So just get used to it. Okay, cosine of pi thirds, I know that's a half, right? Cosine of 5 pi thirds, we're in the fourth quadrant where cosine is still positive, so it's positive, so this ends up being -3 halves. Y is -3 sine 5 pi thirds. Sine of pi thirds is √3/2. We're in the fourth quadrant, sine is negative, so we end up with a positive 3√3/2, and therefore our new rectangular coordinate is -3 halves, 3√3/2. Right? So to go from polar to rectangular, you just do r cosine theta, r cosine theta. All right, so I want you guys to take a minute and try the next one. It is -√2, -3 pi fourths. Yes.
Oh, no. He was pointing.
I was pointing.
Oh, yeah, we could. I'll plot the points while you guys are doing that. So.
That's not the point. But
Graham,
That is
Young.
3 halves, so we have 9 members.
So much crap. He's like 4 buckets of these bullets and then.
Guys, I really think -3 pi over 4 is really just
Yeah,
fine.
well, I have like a couple like.
Right?
From like.
Yeah, so wouldn't it would actually be
I have like a couple pistols and I have this like cheating gun.
Very good.
So it's got like the whole like thread coming out the side. Like,
Oh, is it like the drag one or the
it's got like a like.
Oh, yeah, you're not gonna
Hey, Carrie, get an answer yet? Yes.
Yeah, all the ones that I had from when I was little, like.
For the first example, oh, never mind.
Well, I got pretty.
Never mind.
What's your pickup?
Although,
Harrison, Jake Kelly,
Large.
Kai,
Negative √3.
Jack
I got pencil pad.
Like Abby Adams.
That's
We
two.
have an
Okay. Got 1-1.
And so what
Everyone get the correct signs, the correct positives
is like
and
get
negatives.
together for like a team meeting and like kill all of them.
All right, moving on. All right, this last section on your note sheet is, to me, the most fun part, and it's probably the biggest portion of your homework tonight. So what you'll have to do a lot in your homework is convert equations between rectangular and polar. So not just points, but full equations, right? So when we're doing this, we have this little arsenal of all the little formulas that we've learned so far. I tend to ignore this one, and I tend to use these four for all of my problems. So if I have to use that one, I square it. But anyway, so you've got these 4 equations, and you're just going to replace stuff wherever you can and manipulate however you need to in order to convert r and theta to x and y, or vice versa, right? So I'm going to walk you through This first one. So the first one, oh, and you guys have a different problem on your sheet, right? Good choice. Okay. So 3x squared plus 3y squared equals 27. Even if you don't know anything, you should have an idea of something to do first. Divide both sides by 3, right? So you get x squared plus y squared equals 9. What shape is this?
Circle.
Circle with a radius?
3.
3, right? Okay. So we have x squared plus y squared equals 9. Is there anything that, remember, we need to get rid of the x's and y's and have it in terms of r and or theta. Could we replace something?
R equals 3.
R is 3.
R is
Yeah, r, yeah, okay. So x squared plus y squared equals r squared, so replace your x squared plus y squared with an r squared, right? So you get r squared is 9, so r is plus or minus 3.
Oh, I got it, that's right.
Now, if you graph r equals 3, and you guys all have polar, you don't have to actually physically graph it, but I want you to mentally look at your polar coordinate planes there and think about how you would graph r equals 3, where the angle is irrelevant. You just always want a radius of 3, right? So does that make sense that that is a circle? Okay. What if you were to graph r equals negative 3?
It would still be a circle.
It's the exact same graph, right? Which is, so if you need to convert this to polar, you could actually just write r equals 3 and you'd be equivalent, because it gives you the exact same graph. You don't need the plus or minus, because if you graph both plus or and minus, you're just graphing on top of it. Okay, I want you to try and see if you can figure out as many of these as possible to convert from rectangular to polar. So you don't, you're given x's and y's, you want r's and thetas. However you can do it, and sometimes there's more